So in manufacturing, we have this method called acceptance sampling. So that means we randomly select items without replacement. So let me highlight that. Without replacement. And the entire batch is rejected if there is at least one defective unit. Now I have this electronic company who manufacture 6,500 CD. And we know that 70 of those CDs are defective. Now, if I randomly select 3 of those CD and test them, what is the probability that the entire batch will be rejected? So we're looking for the probability that the entire batch will be rejected. But we know that is equivalent to, let me use a different color. It's equivalent to at least one defective unit. So if one of the CD is defective, then the entire batch, so that entire batch of 6,500 CDs will be rejected. So we're looking for the probability of at least one of those 3 CD we select for test were defective, at least one. Now we have to deal with many different scenarios. We have to deal with all 3 are defective. Or we have to deal with the case, and plus we have to deal with the case 2 of them are defective. And then are we talking about the first 2 or the last 2, or the first one and the last one? And also we have to add that to the scenario. Only one is defective, but which one? The first one, the second one, or the third one? So you see that calculation is actually a little bit complicated, and we won't learn it until module number 5. Instead of carry out this calculation, let's consider the opposite case. The opposite of at least one is defective. So let's draw a diagram over here. And here we have the case that at least one is defective. The opposite of that is none of them are defective. And we know that when we take the test, one or the other will happen. Either none of them are defective or at least one is defective. So if we cannot calculate the probability of at least one, what we could do is we could calculate the probability of the opposite, and then we use the idea of complement, subtract this probability from 1. We will get the probability of at least one is defective, or the entire batch will be rejected. Now that probability is a little bit easier to calculate. So probability of none of the CD we choose, none of the 3 CD we choose are defective equals, when we choose the first one, we have 6,500 CD to choose from, and I'm going to do a little bit calculation at the side. I know out of the 650 CDs, 70 of them are defective. So that is telling me 6,430 CDs are not defective. So this number over 650 6,500. This will give me the probability of when I choose the first CD and that CD is not defective. And because we are choosing 3, so we will be using the multiplication rule. Once we pick a CD out of the entire batch, we will end up with 6,499 CDs. And out of that, how many of them are not defective? So we already chose a non-defective one, so we end up with 6,429 choice. So that will be the second CD. If the last CD is also not defective, well, the probability of getting that one is 6,428 out of 6,498. So from this point, all you have to do is to enter this expression into your graphing calculator. So let's try that. 1 minus, I'm going to go ahead and type 6430 times 6429 times 6428 divided by, and I'm going to put parentheses around my denominator so the calculation can be carried out correctly. So multiply, so I multiply across the top and across the bottom. 6498. Close the parentheses, and this will be my answer. So let me see, 0.031965, etc. So I'm just going to copy the first few digits. What was that? 19658, 19658, and it keeps going. Now, let me read the question one more time. The question asked me to report the answer as a percent and round it to 1 decimal place. So what I will have to do is I will move this decimal point 1, 2 twice. So it will be 3. Oops. So let me do it again. 1, 2 twice. And I want to keep one more decimal place after after 3. So for some reason it doesn't allow me to move. Let me do it one more time. Okay, so I want to keep one more decimal place after 3. So I look at the number after 1 is a 9, so that means I have to round it up. So my answer will be 3.2%. Okay, so hopefully you find this video helpful. If not, please send me an email and explain to me that why you're still confused after watching this video. Okay, thank you very much for watching and have a nice day.